Okay, so we are going to discuss one more problem which is related to theories of failure, and we will try to understand how to solve a given problem which is based on the principal stress theory, principal strain theory, or any other theory that is given in the syllabus. So the problem here given is determine the diameter of the bolt which is subjected to an axial pull of 9 kilonewton together with the transverse shear of 4.5 kilonewton. So they have asked us to calculate the diameter based on the principal stress theory and principal strain theory. So as we have given with the data of elastic limit in tension is 225 Newton per millimeter square, factor of safety is 3 and Poisson's ratio as 0.3. So we'll try to understand this problem and we'll try to solve it. So the problem here given is you have a bar which is subjected to an axial pull of 9 kilonewton in this direction, and you have the shear stress acting in the transverse direction which is of 4.5 kilonewton. And we are interested in calculating the diameter of this bar. So now we'll convert everything into Newton millimeter square so that it will be easier for us to solve the problem. So the axial pull is 9 kilonewton and transverse shear is 4.5 kilonewton. So respectively we are converting it to Newton. Elastic limited tension is 225 Newton per millimeter square. Factor of safety is 3 and Poisson's ratio is 0.3. The permissible stress is sigma y by 3, that is yield stress divided by 3, which is 225 divided by 3 as 75 Newton per millimeter square. Now once you get this, now we'll try to apply the concepts of principal theories or failure theories. So here you can see that the stress which is sigma 1 acting in the normal direction or direct stress, and shear stress is acting in the clockwise and anti-clockwise direction as the shear stress and the complementary shear stress. So you have the sigma 1 as the tensile stress and tau as the shear stress. Now sigma 1 is calculated as P divided by, that is force in this direction divided by this particular area, where area is nothing but pi d square by 4. So now based on this you will get the sigma 1 as 11,459.16 d square, and the shear stress will be this particular shear force which is acting in this direction divided by this area. So again I am getting this as 4.5 into 10 to the power 3 divided by pi d square by 4. So it will be 5729.58 d square. So now these are the two stresses that are acting on the particular element. Now we have to calculate the major principal stress and minor principal stress based on for these two stresses acting on a particular element. So maximum principal stress and maximum principal strain for the above stress condition will be calculated as sigma p1 is equal to sigma 1 by 2 plus under root of sigma 1 p square, sigma 1 divided by 2 whole square plus tau square. This is a general equation that we are getting from the standardized equation, that is sigma p1 is equals to sigma 1 plus sigma 2 divided by 2 plus root of sigma 1 minus sigma 2 divided by 2 whole square plus tau square. Now out of this equation, since sigma 2 is equal to 0, we are simplifying this equation and we are getting this particular part. Now if I solve the values of sigma 1 and sigma 2 tau in this equation, and if I simplify this, I will get the simplified equation as 5729.58 d square plus 8102.85 d square. Now if I add these together, I will get 13,832.43 d square Newton per millimeter square. This is the major principal stress that I am getting. Similarly, if I solve this for the minor principal stress, I am going to get the value of minor principal stress as minus 2373.27 d square. See, you have to remember only this thing, that this plus is replaced by minus this for this condition. Now this is the minor principal stress. Now for using the maximum principal stress theory, we have to consider the maximum principal stress theory criteria, that the maximum principal stress in a material is equals to the permissible stress in that particular material. So now the permissible stress, as we have already calculated, is 75, since the 225 is the given yield stress value. Here we have the 225 as the maximum stress value or yield stress value, and factor of safety is 3. So you are getting this as permissible stress as 75 Newton per millimeter square. So maximum principal stress should not be greater than, or it should be equal to, permissible stress. Now if I can equate this together and if I solve for d, I will get d equals to 13.58 millimeter. Now this is based on the maximum principal stress theory. Now if I calculate the maximum principal strain based on the given stress conditions, this is the maximum principal stress. This is the maximum principal stress that we are getting for all this condition, and this is the minor principal stress. Intermediate one is the 0, or third stress is equal to 0. Now the maximum principal strain is equal to sigma P1 divided by E minus, I'll just correct this, it is sigma P2 plus sigma P3, mu into sigma P2 plus P3 divided by E. Now if I solve this particular part, I will get this as 13,832.43 E d square plus mu is 0.3 and sigma P2 is negative. This is negative, therefore negative becomes positive, so it is minus, so minus becomes plus 0.3 into 2373.27 E into d square. Now if I add this together, I will get this as 145.14544.41 d square. This is the particular value that I am going to get. Now if I equate this to the maximum strain in the normal stress condition, that is the uniaxial stress condition, that means if I equate this to the strain that is generating for this kind of loading condition which is given in the criteria itself, the strain in this condition will be equal to strain permissible is stress permissible divided by elastic modulus, and based on this you are going to get this value of maximum permissible strain. Now once you get the maximum permissible stress and equate it to actual strain value, you are going to get this particular condition, that is permissible strain is equals to the maximum principal strain, and based on this you are going to get the diameter as 13.93. So if you compare the diameters that you are getting in two different conditions, one is d equals to 13.58 and another one is d equals to 13.93. So from these two criteria, it is advisable that you provide the value of d equals to 13.93 millimeter, so that it will be easier or it will be satisfying both criteria. So this is the most important part of this problem, right? So likewise we have to solve different types of problems. We'll continue in the next lecture.